I am going to be collecting those ratios. If you have different ratios, yes, erase your old ones.
Is it supposed to be okay?
4 after the decimal point. 4 digits after the decimal point.
Okay, I know mine right now.
Just put the ruler back in.
It's 11.30.
Yeah,
You
4
already typed your ratios in? You
Okay.
don't even have it open. You sure?
I got 3.0.
Did you actually type it in once I sent it back out?
Mr. Kenny, I don't need that on there. Are we supposed to add? We supposed to add them, right?
Who asked for me? What's up?
Why'd you add them together?
The ratios are right here. Told you! Just type them into the file that's sent back to you. Told you. Look, the very first question is, what is the ratio between the side opposite from the 60-degree angle and the hypotenuse? Opposite divided by hypotenuse. There's your ratio. 0.851. Huh?
Because my thing doesn't look right.
Dude, I need you to put your ratios in this.
I did.
Then you don't need one of these.
Yeah, but you
Raise your hand if you need me to wait longer before I collect the ratios. 1, 2. Amari, I know. All right, if it's only 3 of us, we can go ahead and have conversations about this.
Wait.
I thought you didn't raise your hand, Gabe.
I'll go ahead.
You got your ratios in?
Yeah.
Okay.
Oh my God, gang. Yeah! No. It asked you to do it. I'm with one, that was the first one.
Hold on, I'm gonna restart TR Inspire software.
I'll say something. You go to say that.
I'll
Tell me the truth. You always.
say registration. Yeah.
Oh God. But when you
This is on my stash.
I need too slow.
He told man.
That just be over there, bro. He's gonna say,
Whoa.
What?
Arnold, I got that. Oh, that. Give me that paper.
What happened?
Change it to me now. Apparently we can't hear it. Where's the piece of listener that's not
Exactly. So, dude, he playing. I'm saying 6.5 or 12.
I'm pretty sure I checked them all this morning to make sure they all have it.
Nigga, last class of the day.
You'll put opposite of
Yes.
8.9 for your
You with the phone?
Alright, can I grab everyone's attention? Heads up. So, you should have out your task sheet at this point to take some notes, because instead of just talking within your small group, we're going to look at the entire class's data about the ratio between the side opposite from the 60-degree angle and the hypotenuse. Now, first things first, we all may have set it up very differently, and this is actually just a rough sketch. This is not a perfect 60-degree angle, but let's say that it was a right triangle with 60 degrees. Again, where's my 60-degree angle?
Bottom left. Did you say it?
Did you look at this?
bottom right.
Bottom, oh, my bad, bottom right.
Thank you. Bottom right.
You said.
Okay. Please stop talking, focus. 60 degrees, right here. Which means in the top, it is 30. And I need y'all to take notes on this on that sheet of paper down to the bottom so that you have this to reference in the future. If I made this 60-degree angle, angle A, where would side A be?
What is square? 30?
Say it again. Across from it. Side A is across from angle A.
Write that down.
I should not hear protractors hitting the desk because they are already sitting down while we take notes. Because you're now later going to look at me blankly and be like, I have no clue, Mr. Kinney. No, I directly told you this is it. Side A is across from angle A. So let's say that this right angle is angle C. Where would side C be?
Across.
This hypotenuse over here? So that side across from that angle is side C. And where would angle B and side B be? This horizontal would be what? Side or angle B?
Angle. Side. Side.
Is it a side or is it an angle?
Side.
Okay, so it's side.
B.
So should I write it like this?
No.
Lowercase.
The angle is uppercase on the side.
So this is a final detail that a lot of us need to make sure we clearly understand about these triangles. Angles are uppercase and sides are lowercase.
Let me write it down.
Please make sure you have that as a reference point for the future.
What's your word?
Tyson, literally, come on, man. Are you writing?
No.
You've written all of this up there? On that task sheet? Please understand this is not answering that first question, but it is giving you some important background information so that you understand what I write later. Okay? Anton, have you written all this down? Okay. All right. So let's start looking at these ratios. I know a handful of us are still taking notes, but looks like some of us are already trying to fall asleep. Matthew, get your head up.
It's cold.
It's not cold.
It's
It's not. Just
Either way.
either way, people are going to complain just to complain because they don't want to actually work. Pick up a pencil and do some work.
I know.
Okay.
2 o'clock.
Really quickly, I want you to look at those decimals that are up there, and I will point this out. I keep calling them ratios. Right now, do they look like much of a ratio?
No, it's a decimal.
No. But where did those decimals come from?
A ratio.
A ratio. I will also point this out. What could I'm going to just take this number for example, 0.8367. What could I put in the denominator to make it a ratio but keep it the same number?
1.
1.
1. 0.8367 to 1. That is still a ratio even though it's written as a decimal. And didn't each of these decimals come from a ratio of the side opposite to the side hypotenuse?
Yes.
Yes. Now, I see a clear divide between some of these answers. These top 4 are very different from the rest.
I wonder why.
Well, we're going to talk about it in a little bit, but I want you to look at the rest of those answers. What does it look like, in general, what do you think the side opposite the 60-degree angle divided by the hypotenuse, what does it look like that ratio should be?
0.8 something something.
0.8 something something something? Is that kind of what, did most of us get that as our answer? Now, I will point this out, did anybody get 0.5s anywhere?
Yes.
Yes? Yes? Just not for the opposite divided by hypotenuse?
Yeah, it was adjacent.
Oh, the adjacent divided by the hypotenuse, did some of us get 0.5 there?
I did.
Yeah, I got
Yes?
0.5.
0.4 something? So maybe these people just put it in the wrong spot? Is that a possibility?
Yes.
So we probably need to be careful. But this is an important question. Look again at your task sheet. The task sheet is here. So compare your ratios with others that had a triangle of a different size. Did anybody have exactly the same size within their small group?
No.
No?
No.
So do you think anybody in here really had exactly the same size triangle?
No.
No.
No? Did we get pretty similar ratios though?
Yes.
This is important to recognize. Comparing your ratios with others that had a triangle of a different size, what do you notice? Even though those triangles were a different size, what was true?
They're similar.
They're similar.
They're all 0.
They're similar.
And they're equivalent.
Similar figures.
Hold on, hold on, slow down a little bit. I'm going to come back to what you said in a second, Gabe. We need to be very careful with our language because we're missing out on important information. For example, Kelsey, you said they are all 0.8 something something something. What do you mean by they?
All the answers? All the ratio answers?
All the ratios, but let's go deeper than that. Which ratios?
The hypotenuse. I mean, obviously.
Oh, so that's what we need to be very intentional about because if we're not careful with our language, we're going to miss out on important information. So comparing our ratios with those around us, even though the triangles are different sizes, so even though the triangles are different sizes, Kelsey, you said that the opposite from, and this is important because there was one specific reference angle. Which reference angle? Which one? 60 degrees. Because if I was talking about the 30 degrees, would it be the same ratio? No, because that's the short side, isn't it? So we have to be careful about paying attention to that reference angle. So the opposite from 60 degrees to the hypotenuse was approximately what?
0.8 something.
0.8 something something something? Maybe
Yeah.
0.85 kind of seemed to be in the middle?
I got 0.86.
0.86?
I got 0.8.
0.85?
I got 8.5.
85?
0.8.
0.844, I saw a 0.9 in there. So maybe a little bit higher than 0.85 if we average all those. Maybe a 0.86. Sure, let's go with that.
You know what I said?
Bruh.
So let me ask you this. If you have a right triangle that has a 60-degree angle, what do you think that the ratio for the side opposite to the hypotenuse will always be?
0.86 something.
0.86 something, somewhere around that range, right? Okay, so even though the triangles are different sizes, the opposite from the 60 to the hypotenuse was about 0.86. Okay, what about for the adjacent to the hypotenuse?
I got
There it is.
0.53 something.
Oh, look at that. They're all right around what?
0.5 something.
Hey, did we have a couple people accidentally do the 8s in here?
Yeah, that they.
So do you think they flipped it probably?
Yep.
Be careful. What do you not understand?
0.5.
What do you not understand? You can't say the whole thing. I can't answer that question.
So not time to be sleeping.
Do you not understand why they're the same ratios? Do you not understand where we're getting these ratios?
That
Well, they
calculator.
took the side that was opposite from the 60-degree angle and they divided by the hypotenuse. They followed these directions.
Use the calculator.
It's like once they drew their triangle, here's your 60-degree angle, they measure these lengths and figured out those ratios. Alright. So, let's go back to here and add some more information. So, we already said that the side opposite from 60 degrees to the hypotenuse, remember that's a ratio, is approximately 0.86. And then the side, what was it for the second one? Adjacent to 60 degrees to the hypotenuse is approximately what?
0.51.
0.51? I think we were all right around 0.5, weren't we?
Yeah.
So let's just say
Yeah.
0.5. So even though these triangles were different sizes, the ratio of the opposite from 60 to the hypotenuse was 0.86. The ratio of the adjacent to 60 to the hypotenuse was 0.5. And let's finally look at, what's the last ratio we were looking at?
Opposite and adjacent.
Opposite.
1.65.
Opposite from 60 degrees divided by the adjacent to 60 degrees. Man, wouldn't it be nice if there was a simpler way to write that? Gabe, don't touch him with that ruler again.
I know 0.
So let's look at this opposite to adjacent. We're going to learn about this notation in a little bit. Okay, so we got a little bit different here. But, so these top ones are a little bit different. The bottom ones are a little bit closer, 1.54, 1.66, 1.8. Ooh, I don't think about 24. So this one's a little bit more unsure. Can someone take 0.8598 and do 1 divided by that real quick for me? Have a theory. 1 divided by 0.8598.
1 divided by 0.8598.
Yep.
1.16306.
My theory is completely off then. Someone made a mistake typing that one in. Yeah, I'm going to go ahead and say this. I know what it is. Hold on. I borrow this calculator. I should know this off the top of my head, but I forgot something. Okay, I'll try. So let's say for now, I need y'all to pay attention to this. These answers are the most accurate in here. So 1.5 to 1.86, it's somewhere in that region. So let's say somewhere around approximately 1. I don't know, what would be in the middle of that? 175, 17?
I got 1.63.
1.63?
1.5.
So we go with saying about 1.7?
Yeah.
Yeah?
Yeah.
If you would have round on.
Say again. I mean, that looks like, yeah, that's adjacent hypotenuse. Try that again. That's 13.5 divided by 8. That is not what you put in that calculator to get that number. Okay. So, the big thing I need us to recognize out of this before we move forward is, even though the triangles are different sizes, those ratios for the sides opposite from and adjacent to and the hypotenuse, those ratios, if we did them accurately, were about the same, right, Gabe? Because we're paying attention and not looking at our ruler. Like, come on, man. You're in high school. Focus. two quick things, actually not two, one quick thing before we move on from there. I do want to point this out because this is a question that came up in Austin's group. I don't remember who asked it. But we were struggling a little bit with identifying which side was adjacent to the 60 degrees. Because technically, how many sides are next to the 60-degree angle? Two. So how do we know which one's the adjacent side?
It's across on a 90 degree, right?
Isn't that the
How do I know?
hypotenuse?
It's the adjacent is not the what?
Hypotenuse.
Hypotenuse. So what side, anyone from Austin's group, what side did I say I would recommend identifying first? Hypotenuse. If you identify your hypotenuse first, which is opposite that 90-degree angle, it makes it easier to identify the opposite and the adjacent. So identify your hypotenuse first, so it becomes easier to identify opposite and adjacent. Did you get a ratio that was closer to what? Yeah. Does that make sense now? Okay. From there, let's look at this. Number 2 says, in the right triangles below, find the missing side length and then create the desired ratios between, or based on the angle of reference, angle A and angle D. So two quick things. Angle A is here, angle D is here. How can you find the missing side lengths? Okay, how about this? Everybody pick up a ruler. I want you to measure A to B. Is it 3? You haven't even checked.
Yesterday I did.
So check the length from A to B. Is it 3?
No,
No, A to B.
it's 2.1, look like.
It's 2. So can we assume that the lengths given on the triangle match the lengths on the ruler? No. So we can't say, oh, we're just going to measure it. Come on, guys. I have two sides of what kind of triangle here? Say it again. A right triangle. Hey, how can I find the third side of a right triangle?
Oh, the 60, 90, and 30.
No, ma'am.
You're asking like for the 90 degrees, 60 degrees, and 30. What you asking?
I mean, first off, do I know any of the angle measures?
No.
No, I don't. The only thing I know is that these are what kind of triangles?
A right triangle.
Okay, where does my right angle have to be? So angle B and angle E. I don't know any of the other angle measures. Boys, we're going to split that group up real quick if y'all can't focus. When y'all are working, you're doing well. When you're not, it's bad. I need you to focus. So, I have two sides of a right triangle given. How can I find that third side?
Don't they all add up to
The hypotenuse.
Okay, hold on. Let's go back to what Kelsey said. What adds up to be 180?
All the angles.
don't all the sides?
The whole triangle.
The angles add up to be 180. Am I asking about the angles right now?
No.
And so that's why we have to be careful, and this is why our language is important. Because is there something about triangles that adds up to be 180? Yes. Is it side lengths? No. So that can mess you up if you're not intentional about that language. Come on, guys. There is something you know that connects the three sides of a right triangle.
The hypotenuse. Pythagorean.
Oh! What is that Pythagorean theorem? A squared.
Plus B squared equals C squared.
Which, what do we mean by C? That is my hypotenuse. What do we mean by A and B?
Right angle.
B, okay, so let's talk about this just because this is actually an important thing to be thinking about, but we need to be careful about it. Kelsey said the opposite and the adjacent. But remember how I always said it was opposite from an angle and adjacent to an angle? So we need an angle in reference to that. Does that make sense? So right now I don't have an angle in this equation, so I can't say opposite and adjacent. Okay?
So the ones that are labeled A and B,
Okay, the ones that are labeled A and B, so what about when I have D, E, and F?
just the same thing?
Across, they're across.
It's the same thing, just different.
A,
It'd be
it would be.
B squared, wait, D squared, E squared, and F squared.
A and B are the legs of the triangle.
And
What we mean by legs are the sides that make the right angle.
That support the
and C is the hypotenuse. And so that's another thing to think about. If C is the hypotenuse, A and B are just the other two sides.
So it doesn't matter which one
It does not matter. A and B are just the other two sides. Work within your small groups. We're going to come back together in about 3 minutes, maybe 4. Figure out what the missing side is. Just set up, well, let's go ahead and set it up together. So, in number 2, what would be the Pythagorean theorem for that first triangle? 3 squared
Plus 3 squared equals C squared.
Okay, we need to look at that again.
No, it's 3 squared plus 6 squared.
Why is it equal to 6 squared?
Oh,
Because 6 is the
6 is the hypotenuse.
Okay, 6 is my hypotenuse. My B is my unknown. Alright? Now I need to just solve this equation. What is 3 squared? I'm going to simplify things. 9 plus B squared equals 36. This is just what we did earlier this year when it came to the distance formula. How would I now solve this though? That's the one difference.
Subtract 9 on both sides.
Notice I want to get to B, so what is 9 minus 9?
0.
And notice how I'm creating that equivalent equation, so B squared is equal to 27.
Or would you divide if you had a number?
So let me ask you all a question. Can I divide here?
Oh, you do square
Not,
root.
no.
Square
Because
root.
no,
Square root of
We don't have a number. Well, it's not that we don't have a number, so we'll come back to it in a second. If I'm going to divide, what operation has to be there?
Multiplication.
Multiplication. Remember, division is the inverse of multiplication. What's the inverse of a square?
square root.
Square root. So take that square root and just use the calculator. The square is going to cancel out that square. Just use a calculator. What is the square root of 27?
5.1961.
And for any of y'all that are freaking out, like, how in the world does Zaria know that? She used a calculator. It's not magic. It's not anything other than the calculator is there. So, you say 5.19, Zaria?
Yeah.
Okay. So now you have B. I need you to also figure out what D is and figure out what those ratios are that are indicated here. We all good on that?
Yeah.
Wait, what?
Okay, so you said on the second one we got to figure out B.
You still have to figure out, yeah, because here's angle D, right? You see how this would be side D, that's what's missing. Right? Side D is what is missing. Are there any questions before I release you to find your side and your ratios? Going once, going twice. Sold. I don't want to come to a group and y'all sitting there like, I don't know, Mr. Kenny. Is that clear? Okay, let's get to work. Yeah, turn on lights.